Hello everyone, in this video we're going to learn how to do binomial expansion. But before we start, what I would love you to do is to pause the video here and you're gonna try to expand these questions below. Now you can check your answers with mine here and hopefully you got the same ones. Now we're gonna actually focus on the coefficient of each term for each row. Now on the right hand side, I have listed the coefficient. For example, for the second row, I have 1a, so I wrote down 1, and plus 1b, I wrote down 1 on the right hand side as well. So the next row, you have 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Now, what pattern have you noticed here? Let's have a look at this number 2. Now, if you look at the numbers directly above 2, we have 1 and 1, and we know that 1 plus 1 is 2. Let's try for the next row. I have 3, and the two numbers directly above 3 is 1 and 2. Oh, these two actually add to 3. Same as this 3 as well. And 4 is actually sum of the two numbers directly above it, and 6 is also the sum of the number directly above it as well. So that means I can use the same pattern and find out the next row. So which is 1, 1 plus 4 is 5, 4 plus 6 is 10, 10, 5, 1. And you can keep adding the rows as you go. This is called Pascal triangle. Now let's look for another pattern. In the Pascal triangle, you realize it for each row always start with 1, finish with 1. So you can see 1, 2, 1, 1, 3, 3, 1. Another property is it's actually symmetrical. So let's have a look at this. 1 and 1, this row is symmetrical. 1, 2, 1 is symmetrical. 1, 3, 3, 1 is also symmetrical. Now this property is actually very important for the later video that we're going to watch. So for now, we're going to actually continue other patterns. What did you notice about a's exponent? It's starting from 4, 3, 2, 1, and the last one, in fact, is a to the power of 0, which is equal to 1, so that's why we can't see it. So the a's exponent is actually going down by 1 each time. What did you notice about b? Okay, so the first one, I can't see b there, but you can imagine this is actually the same case, b to the power of 0. And then you have b to the power of 1, and you have b to the power of 2, power of 3, and power of 4. Realize it, b's exponent is actually increasing. Now, we are going to use the properties of the coefficients, which is based on the Pascal triangle, as well as the properties of a's exponent as well as b's exponent, going to help us with the expansion. So we're going to do the same question here, a plus b to the power of 4. The highest power is 4. Firstly, what we're going to do is we're going to list everything vertically so that visually is quite clear. So we're going to actually use the Pascal triangle to help us to identify what to do. Number 1, the exponent is 4. What that means is we need to look at row 4 of Pascal triangle. Now, we just need to be careful for the Pascal triangle. The top row is row 0. It doesn't start from row 1. So it starts from row 0. So this is row 1. This is row 2, row 3. And this one is row 4. That means we are going to use the numbers from row 4 as our coefficient. So we're going to list the coefficient 1, 4, 6, 4, 1. So we're going to do it vertically. So we're going to list 1, 4, 6, 4, 1. Now you probably notice after expansion, we have many terms add up together. So we're going to put plus 4, plus 6, plus 4, plus 1. That is our first step. We know which row of the Pascal triangle's number is going to use. Second one, we're going to look at the first term in the bracket. The first term is a. Now let's go back. You notice that a's exponent started from the highest power of 4 and decreased by 1. So we're going to apply that pattern here. So I'm going to list a to the power of 4 because the highest power is 4, a to the power of 3, a to the power of 2, a to the power of 1, a to the power of 0. Now, I finished with the first term, and remember the exponent for the first term was in the descending order. Now, the third step, I'm going to look at the second term, but you need to make sure that you carry the sign with you. For this case, it's a positive, so I don't have to write the positive. My second term is positive b, and the exponent is going to be in the increasing order. So I'm going to start with 0, b to the power of 1, b to the power of 2, b to the power of 3, b to the power of 4. Now, once you complete it, you're going to tidy up. Everything can be written in a horizontal line. So the first one, I have 1 times a to the power 4 times by 1, so it's actually just a to the power 4. So a to the power 4 plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus 1 times a to the power 0 is 1, and so the last term is b to the power 4, which is exactly the same as the traditional method of the expanding brackets. But traditional method, it takes a long time, and if you make one error during the process, then your whole answer will be wrong. This one will actually help you get the accurate answer. Now, here's the example 1. We have 3x plus 2, the whole thing to the power 4. Number 1, this power 4 tells us I need to focus on row 4 of Pascal triangle, which is same as the previous question, so which is 1, 4, 6, 4, 1. So I'm going to list this number 1, 4, 6, 4, 1. Again, I'm going to put plus in front of each number. I finish with my exponent, which is using, and then get the coefficient. So the second step is I'm going to look at my first term. My first term is 3x. So first term is 3x, and its exponent is in a decreasing order. So because I'm talking about the whole 3x, so I'm going to put the brackets on to the power of 4, 3x the whole thing to the power of 3, 3x whole thing squared, 3x to the power of 1, and 3x to the power of 0. Now that's my first term. And my third step is I'm going to use my second term. For this case is positive 2, so I can just write it as 2. And its exponent is in the increasing order. So I have 2 to the power of 0. Make sure you start from 0. Now remember, in the Pascal triangle, you start with row 0. These powers, the smallest one is also 0. So 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and 2 to the power of 4. You always end with the highest power, which is given in the question. Now what you can do is just tidy up now and then write all of the answers in one row. So for the first one, you can use a calculator to help you, but you can actually do a mental math here as well. So you have 3 to the power of 4. Just be careful because this whole 3x to the power of 4. That means it's 3 to the power of 4 times by x to the power of 4. And you have 2 to the power of 0, which is 1. So technically same as 3 to the power of 4, x to the power of 4, which will give us 81 x to the power of 4. So you can see the final answer here is listed. Okay, let's have a look at the next question. What I would love you to do is pause the video here and try it yourself and come back to check the answer. First step, we see the exponent is 3. So therefore, we're going to look at the row 3 of the Pascal triangle. We're going to construct the Pascal triangle 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. The first one is row 0. Second one is row 1, 2. So this one is your row 3. So we're going to use these as our coefficient. So we're going to list them vertically 1, 3, 3, 1. And because after we expand it, we're adding all the terms together, so we're going to use plus sign here. Now we're going to look at our first term, which is 1, and the power is in the descending order. So we're going to start with times by 1 to the power of 3, that's the highest power, times by 1 squared, times by 1, and times by 1 to the power of 0. And in fact, you realize it, all of the answers will be 1, because it doesn't matter 1 is multiplied 1. How many times? It's still 1. We're going to look at the second term. Now, if you notice that this second term, now we have a negative. The whole thing is negative 2x. And the power is going to be in the ascending order, so increasing order. So we're going to times by the whole thing, negative 2x, please make sure you put the brackets on, to the power of 0, times by negative 2x to the power of 1. The next one will be times by negative 2x to the power of 2. And the last one will be negative 2x to the power of 3. And the last one, the highest power is 3, which is matching with the original question, so that's correct. Now you just need to do your calculation carefully because we have a negative number in the bracket. So for example, let's have a look at the first one. Negative 2x, the whole thing to the power of 0. We know that doesn't matter what it is, it's always 1. The second one, you have the exponent, which is odd number. And I know that negative 2x to the power of 1 is just itself, so this will be negative 2x. However, the next one, you have an even number exponent. So this actually means negative 2x times by negative 2x. So therefore, the final result is going to be positive. So it's 4x squared. And continue with the last one. What you have here is, just be careful with this. I'm just going through this negative 2x thing. Obviously, in the previous step, you still have to times by 3 and times by 3. So that will give you a final result of that row. Here, you have negative 2x times by negative 2x times by negative 2x. Negative is positive, but positive times by last negative is still negative. So for the for the odd number power, you will get the negative answer. So it's negative 8x to the power of 3. And here is the final answer.